Hey guys, Joe Pye here at Advanced Innovations, Austin, Texas. Welcome back to the shop. You know, if you have a quick change tool post on your lathe, sooner or later, you're going to have a situation where you run out of vertical adjustment for the height adjusting thumb wheel screw nut combination on that tool holder. It's going to happen. If you don't have sufficient room around that tool to put a shim under that tool to elevate the tool to put you back within an adjustable range, well, you may have a problem on your hands. I'm going to show you today. We're going to make a little part today, and I'm going to walk you through it step by step. Real easy, real nice little project. It's a great attachment to have in your toolbox. Now let me take you over to the tool post and show you exactly what I'm talking about. If you've been a viewer of this channel for some time, you know that I like to do inverted threading. Now this particular aluminum bar here is a centerline height standard that I have for setting tools. You can see with this tool inverted, it consumes most of the tool holder and it consumes all of the adjustable range. Now in order for this tool to be on center, this has to go even higher, and there is no repeatable way for that to happen. You can set it one time, lock it, leave it in, and do your job, but if you take the tool out and put it back in, you're going to have to go through this all over again. So let's make a little adapter block that goes right here that gives you the adjustable versatility that this particular stud design will not. Okay, the holder that I'm going to use for this demonstration is a B-size Alloris holder, but the mechanics that I'm going to go through in order to produce this little part will be very much applicable to whatever size holder you have. So watch the mechanics, not necessarily the numbers. Okay, we need a couple of dimensions off of this block in order to do this successfully, and these are the numbers that we need. We need to know center to center for the two closest screws, and we need to know the offset from the face of the tool holder to the center of each post. That's not exactly hard to do. Let's collect the easiest ones first. I'm going to measure across the outside of these two here. Set to 0. Now this is all meatball, guys. This really is not a big deal at all. Let's call it 1 inch 672 outside. Now I'm going to go on the assumption that when they made these tool holders, that this is the center of the universe. Everything is symmetrical about that post right there. Shouldn't assume it, but I think it's a pretty safe assumption at this point. Let's go with that. 1 inch 672. How do we know center to center? Well, subtract the diameter, one diameter from this number right here, and under these are 370. Three-eighths 16 imperial thread here. So 370 from 1 inch 672 is 1 inch 302 center to center. Or 651 offset. Okay. 2 times 651 is 1 inch 302. Boy, I don't have my calculator here. I hope I'm right. There we go. Get that calculator. Now when we get over to the mill, just going to have to offset the cutters 651 either way. Now in order to assure that I have clearance for that particular screw, I'm going to go shy on this by about 5 thousandths. So we'll go about 645 off center each way. And when I come in with the end mill to make the slot, I'll go 5 off center each way on the slot as well. And it'll come up with what looks like a larger hole using a 375 diameter end mill. Not a problem. Now we need to know the offset here. Once again, not a big deal. Make sure you're zeroed out. And use it this way. Call it 82 on the gap. And the same thing with the center. If you can't reach the center, take the screws out. Or drive them all the way in. Whatever floats your boat. 372. Now we use the radius of the screw, or the radius of the slug or whatever, and add it to these values. That makes the center 267. And it makes the center value 557. If I have a bunch of working dimensions, calculation dimensions on a drawing that I'm making, the ones that I'm actually going to look at when I go over to my machine, I usually circle them. That way I know that all of this stuff just means nothing. Go with the ones that are circled. It's just the way I work. 267, 557, and 1 inch 302 center to center. 370 on the diameter. And at no time during this demonstration will my hands leave my arms. Actually, no time during this demonstration will I use an edge finder or any other device to do this piece. All right. So if I know the size of my cutter, I can make this entire part without ever needing an edge finder. So let's do it. The material that I'm going to use is 1/2 inch by 1.5 inches, 60-61. And I need a piece that's 1 1/4 inches because it's easier to work with a long piece than it is a short piece. Before I saw off that little blank, I'm going to square up one end. This saves me from having to put a spacer bar on the other end, because you really shouldn't hold short pieces in your vise unless there's a piece of equal size on the other side. Little deburring, quick trip over to the saw. I'm going to slop a piece off and then we'll stand it up and bring it to size. After sawing off the slug, we're now going to sit the prepared surface, the milled surface, on another parallel, fixing up. And I'm going to bring it to 1 1/4 inches thick. I will remove this one time for measurement, and that should be it. $30 more coming off that surface, and if you notice the path that I chose, the rotation of the cutter is driving the chip into the block, greatly reducing the resulting burr on the outside edges. 30 more coming off. Let's deburr the block, clean up the setup, and position this part flat. There you go. Starting blank. Piece of cake. Before we move on to the next operation, let's take a look at exactly how this thing is going to get set up. This is the back jaw of the vise. Looks a lot like a 6-inch scale, but it's actually the back jaw of the vise. So the part's going to sit in there just like that. We're going to have a slot on the left side and the right side, and one in the middle that goes all the way through. Now, if the stationary jaw was up against this part, unless it was aluminum, you wouldn't be able to make this feature right here. You'd have to stand the piece up and side mill it. Well, I don't choose to do that. So I've got a couple of helper blocks in my vise that when the vise comes closed, the stationary jaw will push on these blocks, pinch the part, and allow me access to all three. Once the part is sitting on my parallels and tight, I will remove the parallels because I'm unsure of this distance right here, and I don't want to hit the parallels with the cutter. Especially this one. You'd cut right through it. Anyway, where is this particular area right there? Where is it? Well, funny you should ask, because it's on this page right here. With it sitting in the vise sideways, these are my little helper blocks, stationary jaw. I'm going to bring my cutter down, and I'm going to visually scooch the cutter in until I have a little bit of an land on the end that I like. No particular size. This is completely visual. I'm going to go for about 80 to 100 thousandths-ish, and I'm going to zero my digital out at that point. Now here's where it gets creative. Knowing the diameter of the cutter, once the digital is zeroed at this point, I can offset the radius of the cutter, re-zero the digital, and now I have a working edge for all my holes. No edge finder necessary. Okay. that is going to be pretty clear. Visually line it up to a gap that you like. Zero the digital. Shift the radius of the tool. Zero it again. And now any move you make into the part for finding those holes will be from that edge right there and not from the back. Let's go over the machine and do it. Very much like the drawing I just showed you, this is exactly how I'm going to hold this piece for this operation. Two helper blocks sitting on parallels, rear and front. Let's move that back where it was. Everything is nice and tight. I'm going to take these parallels out. Everything from this point forward is done by eye. Complete meatball. I'm going to shift the machine out of gear and I'm going to rotate the cutter itself so that the flute is towards the back. The center line of the cutter is now this way. I mean, it's center line of the cutter is wherever you want it, but tip to tip on the flutes is aligned with the y-axis. And the table is aligned with the camera axis. There we go. Bring it down just above the part. Line up the rear flute with the rear of the part. Like that. I'm going to zero out my digital and look for around 80 thousandths on the digital. It's about 2 millimeters. I'm zeroing out the y-axis. I'm going to go on my 80. That's because I like the way that looks. And I'm going to zero it out again. Now 0 is the 80,000th step in the back. Now I'm going to offset the radius of the cutter that way, 187, because this is a 3/8 cutter, and zero it again. You want to do all this math beforehand and only make one move? That is entirely up to you. Zero. Alright, this cutter is directly over the wall that will ultimately be cut into this part. Let's do the whole pattern, finding the x-axis center line exactly the same way. Move it into a visual position that you like. If you want to measure it with a scale, let's do it. I know this piece is 1.5 inches wide, so it's 1 1/8 inches. It should be about 9/16 on either side. 9/16. 9/16. Zero out the x-axis. Now we're going to pull up the drawing that we did initially and hit those numbers. No drilling here. I'm going to peck away at this entire thing with this end mill. Now the relief cuts on the top and bottom can be as deep or as shallow as you want. I'm going to go, let's say 100 on each side, just so that there's a nice shelf there for engagement. And plus it's a good round number. And how do we find that? Well, we're sitting right now at 267 to center. You know the diameter of the cutter, therefore gives us the radius. Do a little bit of math and make the offset for your shelf. One of the two parallels is going to need to be returned to the flip side. Okay, these slots are positioned from a theoretical 80 thousandths wall that was calculated into the part before we put the slots in. That being said, the center of this cutter is the edge of that 80 thousandths notch that's about to be put in. If you want to get that 80 thousandths notch, all you need to do is offset the cutter by the radius of the cutter, and you'll get that, because that 0 point right there, that 0 edge, was established by eye before we ever did any of these slots. Okay, one parallel back into part, no parallel under the front, and you're going to understand why here in a second. When this material goes away and we flip it, well, it's not going to have anything to rest on back here anyway. So just rely on the back jaw at this point. All right, well, you caught it right here on camera. Holy mackerel. We just turned that piece of material into a thinner piece of material and completely ignored the wallet I was going to put in the back. You get so caught up in throwing burrs and tool paths. My bad, people. We're going to turn this into the new zero plane as soon as I put in a higher parallel, because I'm going to hit the jaw back here. And we're going to do it right on the second try. Why not, right? What the heck? Just do it as many times as it takes. Dang. Well, it is November, so I guess I get my one mistake for the year out of the way before Christmas, right? Let me get a bigger parallel, and we'll try that again. Oh, my goodness. Okay, we got a higher parallel in there next time. This time I might actually pay attention to what I'm doing. Look for a ridge to form back here. Man. Not cool, Joseph. Not cool. That's how it's supposed to look. Yeah. Effectively, all I did was lose a little bit of thread engagement. I'll do the same thing on the other side. Don't change any of your settings since you're registering on a full thickness part. Everything is the same on the Z height. Okay. I will be kicking myself for that for a while. But you gotta show it, right? You did lose some thickness on it, so whatever you're going to grip on, make sure that your height of this parallel right here will dictate whether or not you have sufficient material back here, so be very careful. Let's just repeat that whole process. The reason I did that on both sides is because if you use this for turning and boring, you're going to have to reposition this as not to hit the movable wedge. In a turning position, the thread's going to be over here, and if you were to use it in a boring position, that's where the movable wedge is. So you have to flip it. Okay. Let's deburr this, figure out where to put that hole. Okay, here's the part in all its glory. A little thinner than anticipated, but hey, nobody's perfect, right? Let's take a look at how it fits and what's going on. What do we have to do next? The screws can still go in. This bite's nice. The edge hits the tool holder real well. One of these legs has to be cut down to the thickness of the block. So I'm going to measure the block, and I'm going to make sure that the distance from the inside of the edge to the end of the part is the same as the block. Now that's because the sliding wedge that goes in there slides up and down, and it's got to have a place to go. So if you don't want that wedge on your allures hitting this holder, well, you got to remove one of these. As far as finding where to put the screw hole, there is minimal play in this because of the way I cut it. I'm going to push it, let's say, all the way down this way and lock it in. I'll take my scriber and go around this knurled nut ever so slightly. Right there. And visually with the inside of the face here. I'm using my finger up against this registration point to give me a nice straight drag. So I'm confident with where that boundary is. Knowing that, all I need to do is position my drill somewhere in this region right here, clearing those two lines, and the screw should operate just fine. Let's get back in the machine, cut this off. I'm going to drill and tap this first so I have a nice parallel surfaces to grab. Then I'll stand it up this way, using a parallel on either side, and cut it off. Let's do it. You can see the ghost line that I scribed in the part. That is the nut. I am 1 inch off that back rail right now, and I'm still using the 0 position from the original milling operation, so I haven't changed anything. I'll stay 1 inch away, and you can see that I'm well clear. That pin right there is the diameter of the screw that I'm going to be using. So I'm going to get close to that line, but I'm not going to crowd it too much. I think we'll call that a day right there. It is visually appealing as well. Okay, let's pop a 1032 hole right at that location. Almost done. The next cut is a clearance cut, so I'm going to work to a scribed line. I don't usually do that, but I'm going to do it this time. Put it on, scribe a line. Let's do it. Okay, just one side, going to cut it off to the scribed line. Here we go. Okay, Listy Bird, check it out. Okay guys, now that you've had a chance to see how that's made, how easy that is to make, go ahead and make yourself one. If you're going to make one, make two, because if you've got a turning and boring operation, you're going to wish you had two. Boy, that is bright, huh? There you go, that's better. Let me show you a couple of other tool holder shortcuts, nifties, tricks, tips, whatever that I've done that have helped out over the years. And you've probably seen this one if you've been around this channel for a while. There are few things in life more frustrating than when you try to, here it comes, unloosen this nut and the whole post spins. It's like, all right, well, that's great. That's a pain in the neck. Well, here's your solution. The end of a file. Stick the end of a file between that nut and the big thumb nut. And when you unloosen the hex nut, this will have a tendency to get sucked in from the rotation of everything and wedge and lock. And when you pop this one loose, the stud is now free. Take it out, clean it, Loctite it, drive it back in with a second nut, put it back together, away you go. It is the end of a file. The file had seen better days. I cut it off, rounded it off, and keep this on top of my machine. Very handy to have. Keep this one in mind. That's a great trick. Second, sometimes you have a tool that is just too small to get below center or above center or on center. So I made a quick little puck that's got a grub screw in it, set screw. That's a 1032. That just simply split and fits over the nut. And to adjust the height below center, there you go. But make sure that if you're going to use a setup like this, and I'll show you this in a second, don't hit the wedge if you have one of these Aloris tool holders. That would be a bad thing. Next trick in line. Set up a tool on both ends of your tool holder. This is a chamfer tool. That is a OD chamfer tool, and that is an ID chamfer tool. So if I want to chamfer ODs, I go like that. I want to chamfer IDs, swap to the other side and go like that. Make sure that the tools that you put in there are ground accordingly so that the height of the center of each tool will come into play. Don't put a 1/2 inch tool on one side and a 1/4 inch on the other. You'll probably have a problem. Next one. This is the one that inspired the video. This is a 3/8 24 threaded aluminum ball. Now actually I have dive gear here that I articulate on aluminum balls. So all I did was thread one of them. And here's the coincidental part. The thread on the top of the tool holder on the B size Aloris, I can't speak to the other sizes, but this thread right here is a 3/8 24. And a 3/8 24 is a very common decorative electrical thread that you'll find in your local home center. Ceiling fans, making lamps, the threaded rods you can get that are hollow, that wires pass through when you make things. 3/8 24. So if you can find decorative ends for the top of the lamp or whatever fixture, chances are it's going to come back to your shop and thread right on. So anything you can do to increase your grip on your tool holder while you're removing it is a good thing. Okay. You can also go and read catalog or McMaster, and you can find all kinds of plastic knobs with threaded inside. 3/8 24 for the B size. Next one, boring bars that are too small to get on center. This little guy here, I may have shown this in past videos, but if you're new to the channel, I'm showing it again. It's just a rectangular piece of aluminum with a step on it for alignment, a slot on the back, and an offset 1032 screw. Make sure you hit not on the wedge when you drop this on. So that goes on the back. And I can do a matter of adjustments with that. That's a boring position. When you invert it, put the screw in from the other side, it can be used for turning. And if you want to change the tool while this thing is in position, make sure that you put these little scallops in there so you can access the screws to get the tool out of the holder. That's a short, dirty, quick little video for you guys. I just got to say, those units, these guys here that offset the tool holder and help you lift it, the ball on the end is a real good one. The double-ended tool, if you're short on tool holders or you just want to cut a couple seconds off a really large production run, do that. and away you go. Turning up a bunch of 303 stainless today. I posted on my Instagram. If you didn't watch it, go check that out. Making a bunch of season 6s today. And this is 303 stainless I'm working with. 1.5" diameter 303 stainless. And of the stainless grades, 303 has got to be the friendliest, easiest to work stainless there is. 303. So if you've heard recently otherwise, that 303 is a miserable stainless, you might want to erase that from your notebook. 303 is awesome. 304, 316, 316L, all of those higher grades are a little tougher. This is mildly magnetic, maybe 5% magnetic, and it doesn't offer the corrosion resistance that 304 and 316 offer. But as far as machinability, I will take this stainless any day of the week. All right, that's all we got for you today, guys. A little bit of tool holder action going on there for you. Try some of these fixes in your shop. I hope they help you out. Thank you for spending some time with me today. Joe Pye, Advanced Innovations, Austin, Texas. I'm out. I thought you might like to see this one. Sometimes this is a little deceiving. This is 303 stainless. This is one of the most enjoyable stainless steels that you can possibly cut. 303. Definitely not the 304 or the 316. 303 stainless, I'm going to take a cut on this. It's about 180 deep. It's about 3/32 of an inch per side. And although the chips are coming off nice and silver like this, if one of these guys was to jump down your neck, it would probably get your attention pretty quick. We put this camera on a tripod and we're going to show you how deceiving it can actually be temperature wise. .303 stainless steel, 180 coming off the diameter, 600 RPM. Watch how hot this is. You get one of those down your neck, you're going to know about it. Holy cow. All right, for all you people driving computers, this one's for you.